Hi everyone, I am Mr. Au. We are here today also to continue on our lesson on the redox. Now today, our lessons will base on redox reaction in aqueous solution. But then, our last lesson, we are talking of key terms. That is one, oxidation, two, reduction. Now, we said oxidation is the loss of electrons. That is, whenever a species loses electron, the oxidation number will increase. And again, we have reduction, and then we said reduction is gain of electrons. That is, whenever a species accepts electrons, the oxidation number or charge will go down. Now today, we'll be dealing with reactions. And then we will balance these reactions using the oxidation and reduction half method. Now, a large number of redox reactions occur in aqueous solution. And then these aqueous solutions could be neutral, it could be acidic, it could be also basic. But we will try and balance redox reaction in these three kinds of solution. Again, unlike acid-base neutralization and precipitation reactions, most of these redox reactions proceed slowly. That is, the acid-base reactions are faster than redox reaction, and also precipitation reactions also are faster than these redox reactions. Now, each redox reactions is the sum of the two half reactions, because we said the name is redox, that is red and ox. It means a full redox reaction should compose of reduction and also oxidation. Now, we have a reaction down that we are to consider. And then this reaction is already balanced. So we will take this reaction and then we try to identify the oxidation half reaction and also the reduction half reaction. That is, our reaction is, we have iodide ion reacting with hydrogen peroxides. And then these two species, when they react, they will give us something like iodine molecule and also hydroxyl ion. And here we have 2 electrons. This side also we have 2 electrons. We balance by putting here 2, and then here also 2. So this redox reaction here is already balanced. Our task is just to identify which of these species is undergoing reduction and which of the species is undergoing oxidation. Now, we have our red and also our ox. Again, this red is reduction, and then this ox is oxidation. Yes, this is in aqueous solution. We also have the what? Hydrogen peroxide in the aqueous solution, and also we can have this iodine in the form of solid. We can also have our hydroxyl ions in aqueous solutions. Now, we consider this charge. That's the charge of the iodide ion in this case. And here we have minus 1, because we just have minus, which implies it is minus 1. Again, hydrogen, in this case, it is plus 1, while oxygen is also minus 1. Yesterday, when we are discussing about the rules, we said oxygen is always negative 2 except in peroxides, where it is minus 1. And in this case, we have a peroxide, and this is called hydrogen peroxide. Now, with 2 electrons, and then it will give us what? Iodine. Iodine in this case is neutral, which means the oxidation number is equal to 0. We also have oxygen in this case, and this is not a peroxide, which means oxygen here is going to be negative 2, and hydrogen will still be what? Positive 1. Now, you see, iodine in this case is negative 1, and iodine here is 0, which means there is a change taking place between these two iodines. Again, we have hydrogen. Here is plus 1, and here also is still what? Plus 1, which means hydrogen is not actually taking place, is not actually reacting in this redox reaction. That is, it is playing the role of spectator ion. We have oxygen as minus 1, and oxygen in this case is minus 2, which means there is also a change going in these oxygen ions. Now, we try to identify which one is undergoing reduction, and after, the species also undergoing oxidation. Now here we have iodine as negative, and here iodine as 0. From minus 1 towards 0, which means there is what? An increment, which means iodine is increasing. Now we come to the oxygen. This is minus 1 going towards the what? Minus 2, which means we have oxygen here minus 1, and here we have minus 2, which means oxygen is undergoing reduction. So in this case, we have here the full species, and then this will give us of hydroxyl ions. But then again, this also, that is the iodine, will be undergoing the oxidation. And here we have to say that is iodide ion will also give us this iodine molecule. Now, if you look at this reaction, you will have here 2 atoms of hydrogen, and this side you will have 2 atoms of hydrogen. You will have 2 atoms of oxygen, and here also you have 2 atoms of oxygen. Now, the charge on this side, that is the total charge of this molecule now, is 0, because it is neutral, while the total charge on this side is minus 2. That is, this mole will multiply this negative side, and at the end we will have here what? Minus 2. And then we have electrons on this side. We have electron on this side. We also have electron on this side. So we need to cancel this charge, or we need to add something in the, on this side, so that the electrons on this side and the electrons on this side will be equal. Or we need to add electron on this side, so that the charge on the reactant side and the charge on the product side will be equal. Now we will take these 2 electrons, that is, we say 2e minus. At the end here it will be 0, and this side is minus 2. which means the total charge on the reactant side here is -2, while the total charge here also is -2. Again, iodine here, that is the oxidation side, iodine is -2. And this side we have 0. So we need this side and this side to be equal. That's why now we will take these electrons and put it on the product side. So at the end, this side is still -2, and here we have 0 plus -2. And then this reaction also will be what? -2. Now in this case, we have identified the reduction half reaction and also the oxidation half reaction. The sum of these two reactions will make up the what? Overall reaction. Now, we have a redox reaction here. That is a sample question or a practice question that you can use and practice at home. That is, tin 4 oxide plus carbon will give us tin metal and also CO. In this case, if you look at this reaction, you should be able to know which species is the reducing agent and which species is the oxidizing agent. With the help of that, you will be able to write your what? Your reduction and oxidation half reactions. Now, we also have redox reactions that will take place in acidic medium. Now, we have a flow chart. That's a diagram that shows the steps involved in balancing half reactions. That is, when you are given any reaction, which is a redox, and you need to balance this reaction in acidic medium, you first balance the other atoms. And after balancing the other atoms, you come and balance oxygen atom. After oxygen atom, you balance the hydrogen atoms. Now, after balancing the hydrogen atom, you come and balance the electrons. Now, whenever the electrons are balanced, the ions also in the reaction will be balanced. Now, the first step is write down the individual half reactions. That is, when you are given any redox reactions, you first write the individual half reactions. And again, you have the first balanced atoms other than hydrogen and oxygen. That is still, you balance the other atoms. Balance oxygen atoms by adding water molecule. Because this is acidic medium, if you are adding any other species that is not given, it's going to be hydrogen ion and also water molecule. Now you balance the oxygen atoms by adding water molecules, and also you balance the hydrogen atoms by adding hydrogen ions. After that, balance charges by adding what? Electrons. Now, you can also multiply the half reactions by integers so that the electrons gain and loss are the same. Because always, at the end of these reactions, electrons are cancelled out. And two electrons, or you cannot cancel two electrons that are not equal. So therefore, you must use an integer or the integer that will help you to make the electron gain and the electron loss to be equivalent. In that case, you will be able to cancel them. Again, we add the half reactions by subtracting things that appear on both sides. That is, if you have hydrogen ions on the oxide and you also have hydrogen ion on the red side, you can what? You can subtract them, and the same thing applies to the water molecules. Make sure the equation is balanced according to what? Mass. That is, after you consider again each atom in the reactant side and also in the product side, whether they are equal or not. And then after considering the mass in the reaction. Now you come and concentrate on the ions. Now, and these ions, with the help of the charges, you'll be able to balance redox reaction in acidic medium. Now, I will write a reaction, and then we will balance the reaction in acidic medium. That is, we can have MnO4 minus Aqueos plus C2O4 2 minus, and this is known as oxalate acid, plus hydrogen ions, which is telling us the reaction is taking place in acidic medium. And then this will produce manganese 2 plus in the form of aqueous, and also CO2, which is a gas. And finally, water molecule is also produced. Now, we have a redox reaction here, and then we are asked to balance this reaction using the oxidation and reduction half method. Now, I will first identify my reduction side, and then I will balance the reduction side. After, I will identify the oxidation side, and then I will balance that side too. Now here, if you calculate the oxidation number of manganese here, you will have plus 7. You calculate the oxidation number of carbon in this case, you will have plus 3. Of course, manganese here is plus 2, and carbon in this case is plus 4. So these are the main species undergoing the change in this reaction. Now we have manganese here is plus 7, while manganese here is plus 2. So which means manganese is undergoing reduction. Now we have here the species undergoing the reduction, and here we have Mn2 plus, that is the product. Now, the first rule says we balance other atoms. Here we have manganese, and here we have manganese. But manganese here is 1, manganese here also is 1, which means the manganese atoms are balanced. But oxygen here is 4. Well, there are no oxygen atoms on the product side. And then when balancing redox reactions, we can add hydrogen ions and also water molecules. Water molecule is containing what? Oxygen atoms. Which means if we put it here, we still have oxygen on this side and oxygen on this side. Water is having hydrogen. That's why we need to add hydrogen ion on the reactant side. Which means we'll first put here water, so that we'll have what? Oxygen. Now, the oxygen here is 4, and the oxygen here is 1. So we put here 4 to balance the oxygen atoms. There is hydrogen, there is no what? Hydrogen here. So we can still add what? Hydrogen ions. And hydrogen in this side is 4 times 2, which is 8, and here is 1, which means we add here 8, so that we will have a balanced reduction half reaction. Now in this case, all the atoms are balanced. We move towards the what? Electrons. Manganese here is plus 7, while manganese here is plus 2. Now we consider the change from this plus 7 to this plus 2. which is a difference of 5. Which means also the difference between this manganese and the difference between this manganese is 5 electrons. And then these 5 electrons, we said it is what? Reduction. Which means it is what? Gain of electrons. So we can rewrite this equation as ions, gain of electrons. The reduction, always you gain electrons at the reactant side. That is, we'll have plus the difference between this and this, which is what? 5 electrons. This will produce the same products. That is Mn 2 plus 4 moles of water. Now let's see whether our reduction half reaction is balanced. The mole here is 1, while the charge here is minus 1. So 1 times minus 1 will have minus 1. This 8 times plus 1 will have plus 8. And this is 5 times minus 1, we will have minus 5. We come to this side also. We have plus 2, because this is 1 and this is 2 plus. So you'll say 1 times 2 plus, and you still have what? 2 plus. 4 times 0, because this water is neutral, now the charge here is 0. Now it's going to be 2 plus 0, which means this side is 2. And now this side also now, this and this will have minus 6. And minus 6 and plus 8, we will still have plus 2. Which means our reduction half reaction is balanced. After this, we come towards the what? That is the oxalate acid, which will be undergoing oxidation. Of course, we just have 2 species here. If this species is undergoing reduction, it means the next species will be undergoing oxidation. So here we will have C2O4 2 minus. This will give us CO2. Now the rule also says, if you can balance any half reaction without adding hydrogen ion or water molecule, you can balance it like that. But if you cannot balance without adding, then it means you must add water molecules and also hydrogen ion. In this case, we add hydrogen ion and water molecules because without these 2 substances here, this reaction will not be balanced. Now, carbon here is 2 and carbon here is 1, which means they are not balanced. But I can simply add 2 here. So carbon here will be 2 and carbon here will be 2. Oxygen here is what? 4. And oxygen here is 2 times 2, which is going to be 4. Which means in this case, the atoms also are what? Are balanced. The atoms also are balanced. But then, the charge of the reactant side, in this case, there's nothing here, which means it is 1. Now this 1 mole times this 2 will have minus 2. And this is 2, this is neutral, times 0 will have 0. Which means these 2 electrons, or this the oxidation reaction is not balanced yet. Now we'll consider also the difference between this plus 3 and this plus 4. This is 3 and this is 4, which means the difference is just what? 1. But then we have 2 atoms undergoing the same chain. That is, the first atom, the difference is 1. And the second atom also, the difference is 1. So at the end, when you add this 1 plus 1, you end up having what? 2. Which means the difference between this plus 3 and this plus 4 is 2 electrons. Because you have 2 carbon atoms that are undergoing the chain. Now here, oxidation also means loss of electrons. And then you lose electrons at the product side. Of course, if you put here these 2 electrons here, the reaction will not be balanced because this side will continue to be -4 and this side will still be 0. In that case, the reaction will not be balanced. And the only possible place where we can add those 2 electrons is at the product side. At the end, we will have 1 times -2, we have -2, and this side we have 0, and here we have -2. So at the end, this side is -2, and this side also is -2. Now we have a balanced reduction and also a balanced oxidation half reaction. Now the next thing here is to balance the overall reactions. In balancing the overall reaction, we'll bring these 2 reactions together and then we balance their electrons and also including their number of atoms. Now we have overall reactions. And then in this case, this one is the balanced reduction half reaction. We'll put it here. MnO4 minus plus 8 hydrogen ions plus 5 electrons. This will give us Mn2 plus 4 molecules of water. We also have the oxidation half reaction, which is already balanced. We also bring it in this case. That is C2O4 2 minus will give us 2 molecules of CO2 plus 2 electrons. Now, if you want to balance the overall reaction, the gain of electrons, that is the number of electrons that are gained in the reaction and the number of electrons that are lost in the reaction should be equal, so that at the end of the reaction you can cancel out the electrons. And then the electron gain in this case is 5 and the electron loss in the second reaction is 2, which means they are not equal. So what we'll do is we take an integer. Even without that integer, just use the number of what? Electrons. That is, the number of electrons of the oxidation side is 2. So use that 2 and multiply it by the what? Reduction side. The electron gain by the reduction side is 5. Use that electrons and multiply it by the what? Oxidation side. So at the end here, so in this case now, we will have 2 times 1, we will have 2. That is 2 MnO4 minus plus 2 times 8, we have 16 hydrogen ions. We have 2 times 5, that's going to be 10 electrons. This will give us, we have 2 times 1, still we have Mn2 plus 2 times 4, which is going to be 8 water molecules. We also multiply the oxidation reaction by 5. That is 5 times 1 also, we have 5 C2O4 2 minus plus, now this will give us 5 times 2, we have 10 CO2. We again have 5 times 2, we have 10 electrons. Now you see, the electron that are gained in the reduction side is equal to the electron that are lost in the oxidation side. And the rule says electron must cancel out electron, which means this 10 here can easily cancel out this 10. If this side was containing something like water molecule and hydrogen ion, that is the oxidation side, then or therefore we will subtract hydrogen ion, we subtract the hydrogen ions, and water molecule, we subtract the water molecule. Since there are no hydrogen ions and water molecules on the oxidation side, we can now write our overall balance reaction. That is the full reaction. In this case, we will have 2Mn minus plus. This place will move to the what? Reactant side. We are again trying to write a reaction like this one. And again we have 5CO4 2 minus plus 16 hydrogen ions. This will give us 2 moles of M2 plus 10 CO2 plus 8 water molecules. Now, let's try and confirm whether this equation is balanced or not. First, we try to check whether the mass of the equation is balanced. And to check the mass of the equation is balanced by looking at the number of atoms. Here we have, for manganese, we have 2 this side. And manganese this side also is 2, which means the manganese is balanced. Oxygen here is 2 times 4. And 2 times 4 is 8. Oxygen here is 5 times 4. And 5 times 4 is 20, which means we have 8 plus 20, which equals to what? 28. That is, oxygen this side is 28. Let's check oxygen this side also. So here we have 10 times 2, which is 20, and 20 plus 8. For this oxygen, we still have what? 28, which means oxygen also is balanced. Hydrogen ion, this side is 16, and hydrogen ion, or hydrogen atom this side is 8 times 2, and 8 times 2 is 16, which means the mass of this reaction is balanced. Now, we consider also the charges, whether they are balanced or not. In this case, we will have 2 times minus 1, which is going to be minus 2. 5 times minus 2, we have minus 10. 16 times plus 1, we have plus 16. And if you do the mass in this case, you will end up having what? Positive 4. And in this side, you will have 2 times plus 2, which is going to be plus 4. This is 10 times 0. Because this CO2 is neutral, then therefore we'll have 0. This side also will have 8 times 0, which is still going to be what? 0. At the end, our reaction, or the reactant side here, we will have plus 4, and the products here also we have plus 4. Now with this, we have a balanced mass reaction, and also the charges also are what? Balanced, which means this equation is balanced. And here we have the steps of balancing these reactions. Now, you can try this equation, that is a practice equation, that is you have Cr2O7 2 minus plus iron 2 plus hydrogen ion will give us chromium 3 plus iron 3 plus and also water molecule. You can try this equation and then you see whether the equation will be balanced or not. Now, when you try to balance this equation, always follow these steps and then you will be able to balance this equation correctly. And after balancing, check whether the mass of the equation is balanced. That is by looking at the what? Number of atoms. And after, you balance the what? The charges. If the number of atoms on this reaction are equal and the charges are not equal, it means there's a problem on your reactions. Now, that was redox reactions in acidic medium. Now we also have redox reaction in basic medium. Now some redox reactions requires basic medium to occur. In this case, the following steps need to be performed to balance the reactions. That is, we can have number one, these are the steps that we need to balance redox reaction in basic medium. One, assign the oxidation numbers. You first try to calculate oxidation numbers of the what? Of the species, so that you will know which species is oxidizing and also which species is reducing. Number two, balance the other atoms, just like the what? Acidic medium, and also separate the half reactions. That is, you have your reduction half reaction aside and your oxidation half reaction aside. Three, separate the half reactions. That is, you what? You separate them into red and ox. Add water molecules to balance oxygen atom, whatever side deficient in what? In oxygen. In this case, you know, acidic medium, we were using hydrogen ions and water molecule. Now for the basic medium, we'll be using hydroxyl ion and also water molecules. Because according to some scientists, a substance cannot be called a base if it cannot produce hydroxyl ion in 1 mole of its solution. Again, also, you can add the same number of hydroxyl ion to the other side. That is, if you add water molecule on one side, you can add hydroxyl ion on the other side. Balance the charge by adding electrons to the appropriate side. That is, by looking at the what? Difference in what? In electrons. Now, balance the electron loss or gain by multiplying the electrons by integers. That's the same thing as we did in this acidic medium. Now, add the two reactions, removing any duplication if any of the common species on either side. That is, after balancing the basic medium, and then we have hydroxyl ion on two sides, which means it's duplicated. Then we what? We subtract. If we have water molecule on two sides, it's duplicated, we subtract. But whenever we have electrons, and then the electrons are equal, we must cancel out those electrons. Now we have two reactions here. That is, balance the following reactions in basic medium. I will try and guide to the balancing of the first reaction, and then you will try and balance the second reaction. Now here we have MnO4 minus, of course, it is aqueous. Now this is reacting with iodide ion, which is also aqueous, and this will give us MnO2 plus iodine, this plus iodide ion plus iodide ion. Now again, we have another reaction which is taking place in basic medium. This reaction is taking place in basic medium. Now again, we will first identify the reduction side, and after we balance also the oxidation side. Now manganese here is plus 7, iodine here is minus 1, manganese here is plus 4, and iodine here is plus 5. You can confirm or verify these oxidation numbers when you calculate the oxidation state of the corresponding atoms. Now, we first identify the one undergoing reduction. And manganese here is plus 7, and here it is plus 4, which means manganese is reducing. So, we will have MnO4 minus will give us MnO2 O2 solid. MnO2 solid. So let's try and balance the atoms. Here we have manganese 1, and here also we have manganese 1. We have oxygen 4, and here we have oxygen 4. So if we add 2 here, the oxygen will be 4, but the manganese also is going to be 2. So therefore, we need to add 2 here also. And if you do so, this manganese also will be 2, and then it will increase the oxygen atoms to 8. So which means we try and add water molecule and also hydroxyl ion, because basic medium we need OH minus and also water molecules. Now we need to add the OH minus to the side containing less oxygen, and this is 4 and this is 2, which means this side contains less oxygen. Therefore, we will add here hydroxyl ion. Now, if we add hydroxyl ion here, which means we must add water molecules on this side. Now, on the reduction reactions, we identify this species is undergoing reduction. So we write MnO4 minus, and this will give us MnO2. So we can add hydroxyl ion and water molecules. We can add hydroxyl ion and water molecules. And we always add hydroxyl ion to the side deficient in oxygen, which means this side will be OH minus. And if that's the case, we must add here also water molecules. So the method of balancing here is called trial and error, but then if we put here 4, we put here 2, then the equation will be balanced. We can say manganese is 1, manganese is 1. So water contains 2 times 2, that is 4 atoms of hydrogen. Here also we have 4 atoms of hydrogen. Oxygen here is 2 plus 4, and oxygen here also is 2 plus 4, which means the atoms are balanced. Now the electrons, we can say MnO4 minus plus 2 water molecules will give us MnO2 plus 4 hydroxyl ion. Now the difference between this plus 7 and this plus 4 is 3 electrons. And those 3 electrons means gain of electrons. Therefore, we add those 3 electrons here. Now it means this is minus 1, this side is 0, and this is minus 3. And here also we have what? Minus 4. That is 4 times minus 1. And this minus 1 minus 3 is minus 4, which means the reduction side is balanced. Now we move to the oxidation side. That is the ox, where we have I minus will give us O, that is IO3 minus. And again, iodine is 1 here, and iodine is 1. Oxygen, and there is no oxygen, which means we add oxygen, or we add hydroxyl ion to the side deficient in oxygen. There is no oxygen here, so we can add there the hydroxyl ion, and there is oxygen here. We can add here the water molecule, because if you add hydroxyl ion on one side, you must add water molecule to the other side. And in this case, you can balance it by adding here 6 and then putting here what? 3. So this is going to be 3 plus 3 for oxygen 6, and oxygen also is 6. 3 times 2 for hydrogen is 6, and here also we have what? 6 for hydrogen ions. Now we have iodine minus 1, and also we have iodine here is plus 5. So the difference between this iodine and this iodine here is 6 electrons, which means we put here 6 electrons. Now here we will have minus 1, minus 6, and here we will have minus 1, minus 6, which means here we will have minus 7, and this side also will be minus 7, which means we have the balanced reduction set and the balanced oxidation set. Now we balance the overall reactions. Now here we'll have MnO4 minus plus 2 water molecules will give us MnO2 plus 4 hydroxyl ion. And then we can have I minus plus 6 molecules of hydroxyl ion will give us IO3 minus plus 3 water molecules plus 6 electrons. So the rule says electrons will cancel out each other. Electrons will cancel out each other. And this electron is not equal to this electron. So it means we multiply this side by this electron, which is going to be 6. We multiply this side by this electron, which is going to be what? 3. So the overall reaction here that we'll be having will be something like 6 times 1 here we'll have 6 MnO4 minus plus we'll have 6 times 2 we have 12 water molecules plus 6 times 3 we have 18 electrons. This will give us we have 6 MnO2 plus we have 6 times 4 that's going to be 24 hydroxyl ions. Again, we have 3 times 1, which means we have I3 plus 6 times 3, which is going to be 18 electrons, 18 hydroxyl ions, sorry. And this will give us 3IO3 minus plus 3 times 3, we have 9 water molecules plus 3 times 6 we have 18 electrons. Now with the help of this we can write our overall reaction. Now you see the electron here which is gained and the electron here which is lost are equal. This is 18 and this is 18, which means this can cancel this. We have here 18 moles of hydroxyl ions and here we have what? We have 24 moles of hydroxyl ion, which means we will subtract this from this value. That is, we subtract this 18 from this, and then we will have something like 6. Again, we have 9 molecules of what? Water. And here we have 12 molecules of what? Water, which means we will subtract this 9 from this 12, and then we will have 3, which means at the end of this reaction, we'll have 3 molecules of water, and then we have 6 molecules of hydroxyl ions. Now our overall reaction now is going to be 6 MnO4 minus plus 3 iodide ion plus 3 water molecules, and this will give us 6 MnO2 plus 3 IO3 minus, and then we have plus 6 hydroxyl ions. Now let's check where this reaction is balanced by looking at the charges. Here we have minus 6, that is 6 times minus 1, which is minus 6. We also have 3 times minus 3, we have minus 3. 3 times 0, we have 0. And this we have minus 9. And this set, 6 times 0 is going to be 0. We have 3 times minus 1, which is going to be minus 3. And then we have 6 times minus 1, which is going to be minus 6. And at the end, we have minus 9. Now you see this reaction, the reactant side, we have minus 9. And the product side, we have minus 9, which means this equation is balanced. Now you can try the second redox reaction, which is chlorine gas produces chloride ion and also trioxochlorate 5 ion. And this type of reaction is called disproportionation reaction. That is a species or a reaction in which the same species will undergo reduction, and also that the same species is still undergoing the what? Oxidation. So now with this, we come to the end of this lesson. Till next time, or till we meet again.